So example number 2 here, this is our interpreting graphs, okay, describing a possible situation for a graph. This graph represents a day trip from Athabasca to Kikino in Alberta, a distance of approximately 140 kilometers. Describe the journey for each segment of the graph. So here's our graph, and again, some key characteristics of a graph. We have a nice title. We have labels with units on both axes. We have a representative scale for both sets of data, and then we have some kind of graphical information. Okay, so those are some key things that need to be included on all graphs. Okay, so be aware of that when we get to that graphing assignment that's coming up. So what's happening on each part of that trip? So we're going to divide this trip up into 1, 2, 3, 4, 5 sections. 1, 2, 3, 4, 5 individual sections, and talk about them individually. So what's happening from our starting point to letter A? So we start in Athabasca, driving towards Kikino. Can we be specific about some information? Sure we can. Takes about 2 hours. Takes about 2 hours to do what? To drive about 140 kilometers. So that's what we say. From 0 to A, the car takes 2 hours to go 140 kilometers to Kikino, travels at a constant rate. Because it's a constant rate, or the reason I know it's a constant rate is because we get this straight line in this line segment here, 0 to A. If this was not constant, then this line would bend or skew or do something funny. So this is a constant rate from Athabasca to Kikino. What happens at spot number 2, A to B? Well, the car doesn't travel anywhere. Distance does not change, right? The time changes. The time changes by about an hour. So what's happening? Well, they take about an hour before they decide to turn around, and looks like they go back home or back to Athabasca. So we just simply write that. Car stops for about an hour. There's no distance change, so it's standing still. Section 3, B to C. What did I write down here? It says the car takes about 45 minutes to travel away from Kikino towards Athabasca. So B to C, that's this section right here, B to C. Again, you can see, well, the time frame is about 45 minutes. 3.5, 3:45, so about 45 minutes to travel approximately, well, whatever this distance here is, 20, 40, 50 kilometers. I don't think I wrote that in there. 10, 20, let me make sure that's right. 100, 120, 140. That's 90, 50 kilometers. So I should add that in here. B to C, the car takes about 45 minutes to travel away from Kikino towards Athabasca for about 50 kilometers. So this is all information that I'm getting right off of my graph. I'm interpreting information that has been given to me on the graph. And this is called, and we're going to talk about two terms eventually. We're going to talk about interpolation. Interpolation, which is looking at info or information that's given to you in the graph. Look at info given in graph. Okay, as opposed to extrapolation, where we try to, well, the term is extrapolate. We try to extrapolate outside of what's given to determine what may happen. So there's a difference between interpolation and extrapolation. Interpolation, you look at information that's given to you on the graph itself. extrapolation is, well, if we wanted to maybe continue this line down this way here and maybe say something about what might happen over here, well, that's extrapolation. Now, of course, we couldn't do that with this graph, but some graphs with linear equations we can. This one not, but at least now you have those definitions. And those should have been definitions that should have been discussed in grade 9, so hopefully they're not new to you. So where did we get to? We are at C and D now, this section right here. What happens again? C to D? Well, there's no distance change, so the car must be stopped. Okay? So there's no distance change. The car stopped again for another 45 minutes. Car stops for 45 minutes. And then our last section, D to E. Okay? Again, constant rate traveling back towards Athabasca because the distance is getting smaller. Okay? But this overall distance that they travel is 90 kilometers, so the car takes about another hour to travel 90 kilometers and then end up right back where they started at Athabasca. Okay. So that's just looking at information given to you on a graph.